I'm going to go the extra mile here and actually go ahead and make sure that the changes that Jules has actually made do work. The past week has been quite exciting for the vibe coders among us because not only did OpenAI release an agentic software engineering tool called Codex, but now Google has entered themselves into that same ring with the introduction of what we see right here called Jules. Now, first and foremost, I do just kind of want to mention out in the open here that I've not done a ton of reading about Jules or a lot of research with it. If this is something you actually do want to play with, all I had to do personally was just sign up with my email that I was interested in testing it. And then I think like a few hours or a day later, I got an email saying, okay, you've been granted access to play with this. Nothing special was involved. So I would imagine that for anyone interested in doing the same thing, your experience would mirror mine, hopefully. Now, once we are actually in this, the only thing I've done here is just basically clicked connect to GitHub and chose to allow it to either access all of my repositories or select a few repositories that it would access. I chose to just allow it to access everything. As you can see right here, all of my public repositories are actually listed here. Now, something that I know a lot of folks took issue with, or not issue, but were concerned about with Codex when I did a video on that is, are they going to use your GitHub repository data to train these models? So in OpenAI Codex, when setting that up, there was basically a toggle button where you could either choose to allow or disallow training of the model on your data. And in Jules here, when I actually connected it to GitHub, I didn't see anything like that. So fortunately, I am happy to report that up here in the settings icon, if we click it, we can basically go ahead and choose to allow or disallow the model to be trained on our data. So honestly, I just don't really care for any of these repositories here. So I am going to just leave everything the default way that it is right now. But basically with that, I think we're just going to jump right in and start playing with this and get a feel for it and see how Jules stacks up to Codex. So just as I did with Codex, I am going to opt to use the repository for my social robot, where basically you can just kind of get everything to build this from this repository. Obviously you have to 3D print and buy electronics and stuff, but the software for it is basically a Unity game running a social companion chatbot. It is open source, and as we can see here, it is highly popular. So with that, we're just going to go back into Jules right here. I have selected that repository from the dropdown, and then you can actually go ahead and select the specific branch as well. Being that there only is one available for that repository, we will opt to stick with that. Now, I am basically just going to first and foremost ask it to essentially sum up what this repository is and try to pick out some important parts of this repository that would be pertinent for someone working on it to know about. So a basic general but good first introductory test for this, I would say. Now we can see up here that Jules is experiencing high load. Tasks may experience increased latency. So there's a lot of people who want to play with this right now. So my task is queued and will start shortly. And being that this is the first time that I have actually played with this, I have not done anything with this off camera or anything like that. I suppose this is acceptable, so I will fast forward until the task actually begins to occur. All right, after a little bit of time, it has begun, and the first thing we see right here is just that it is cloning the GitHub repository, and it seems to be beginning just by reading through the README, so that is definitely good practice for any of the vibe coders amongst us. All right. So so this seems to be some outline or plan of action that it is going to follow, and it's just basically showing me about that. It has created the plan to gather information about the repository, identify key scripts, and suggest potential improvements. Please review it and let me know if you have any feedback. Cool. We'll just take a look at what the drop-down arrows here show us. Okay, so mention the Arduino sketches, highlight the Unity project folders, and point out the C# scripts in the local LLM for LLM integration. All right, not bad. So it did craft this plan based off of what it actually saw when it cloned the repository. Okay, well, I'm glad this was on camera because I'm like 89% sure that I didn't just click approve, but maybe it auto-approved it or something like that. I am not sure. So while it is working, I guess I will just start going over some of the things that it is identified here. Now, obviously, some of these are fairly simple, and as I had said for Codex, just basically giving a summary of this repository could be done by a much simpler, smaller local LLM because it can see the README and understand the gist of what the repository is aimed to accomplish. However, beyond that, I find what's interesting is when it goes in and starts to identify the important information pertaining to the actual scripts that it finds important. So it did mention some of these README PDFs are important because they kind of guide you through getting the necessary parts and things to actually build the physical robot. But beyond that, it did mention the Arduino sketch, but more importantly, and what I'm more interested in, is seeing what specific C# scripts or Unity project scripts it actually sees as very important. So it does notice that the RoboListen and the RoboLogic scripts are very important. And truth be told, I do believe that this was the same identified scripts that Codex did, basically saying these are very important. It says C# scripts is specifically provided for integrating the robot with a local large language model via Ooga Booga's text generation web UI. So that is correct, and that's cool. It doesn't give me a whole lot of specific info about them. And something I noticed Codex did that I'm not seeing right here is Codex actually had a little source citation mark where if you hovered over it, it actually showed you what specific lines in the specific scripts it was referring to. So that was nice to see. But basically it did actually... Now this I will actually find interesting. So the face adjustment projector README. So if you look at the robot right here, the face is projected onto, call it a piece of plastic, but actually getting that aligned properly is an integral part of actually setting it up so it doesn't look bad. So it did actually identify that as something important, which I suppose was pretty good. So we'll just kind of scroll on down and see what else is here. So in summarizing the key software functionalities, we can basically see that it kind of went ahead and reiterated some of the things it mentioned right here. It just gives us a little bit more information about what some of these scripts do and not necessarily why they're important, but these are the most important scripts here. So we can give it an A+ for that, I suppose. And now we have suggested potential improvements, which is always interesting because it has the potential of making me look bad live on camera. So all right, enhance inline comments within the Arduino sketches in C# script files, especially those in the local LLM and Unity projects, would improve readability and maintainability for other users or contributors. So to all 12 of you right here, I do have to, all 11 of you right there, I do have to apologize. Dependency management for Unity, okay. Alternative hardware exploration. That is actually interesting and something that I didn't see Codex. So what I'm noticing right here, just first and foremost, is that this seems to be taking a more general look at the repository, where Codex was very software specific. So Codex didn't really talk about many of the PDFs or anything. It fixed one link to one of them, but it didn't really talk about anything like this, like suggesting other hardware like an ESP32 as opposed to an Arduino or something like that. That is interesting just to note. And again, that's kind of the gist of this video, is just like a hands-on test to get a feel for it. Software testing framework, introduce automated tests for the C# and Unity scripts. Okay, so unit tests and things like that. Centralized and version controlled documentation. So again, kind of like quality of life things right here. Version control for 3D models. That's interesting. Definitely not something I'm going to do, but that's interesting because the 3D models are what they are. I'm not touching those again. Error handling and logging. Okay, so kind of just like some generic, I suppose, best practice and quality of life suggested improvements right here. A contributing file to guide users who want to contribute. That's pretty good. All right, and basically, so I am kind of wondering, is this the same thing that we're seeing right here with what I believe is purple text? Okay, so basically it did what I asked it, where it went ahead and gave an overview of the repository. So I'm thinking about just giving it a simpler task, just asking it to, fully quoted from what it said, enhance the inline comments within the documentation. I mean, I guess if I was a viewer watching this video, I'd be like, well, that's a really boring test. So to be honest with you, I think I'm going to bail on that, and we'll ask it something more complicated, basically saying, please modify the API call in the robologic.cs script to go to the Google Gemini API, and then we'll see how it's capable of doing that, and if so. And I don't even know if I want to mention the specific script that the API call happens in. I kind of want this to figure that out on its own. All right, so we're asking it a more complicated task. Okay, and it's experiencing heavy traffic. It might take longer to respond, which is, of course, to be expected, especially because, I mean, part of me wants to be like, what is this? It's so slow. But then the other part of me is like, well, it's free. So, And then that's why I basically just am not going to comment on that. Obviously, a lot of folks are going to be wanting to play with this. So, and I do believe Google had announced a $250 a month plan or something like that. And I would imagine something like this will be included in that with hopefully no limits, or with like very, very fair limits, if you will. So we'll kind of see what it does here. And then this will be a better test of its actual coding capability. So it actually responded far quicker than I had expected it to based off of the message that popped up, which is cool. And basically it just thanked me for the feedback, which is nice to see. I understand you'd like me to modify the LLM integration to use the Gemini API. Good. And basically, so again, we kind of see its course of action right here, I suppose, as you could call it, whatever, or plan of action, whatever. And basically, it immediately knows to modify the robologic.cs script, which is absolutely the correct course of action. So basically, if we just quickly go into one of those, if we go into asset scripts, oh, here, I've forgotten my own code. So basically, in this script is where the actual API call gets made. So it would have needed to really understand this script to immediately point this as the place where the API integration needed to be modified and implemented. So that is cool to see. And it is first and foremost starting out by researching the proper methodology or documentation to actually go ahead and do this. Request structure, how to include the API key in the post method. This information is sufficient to proceed with modifying the C# scripts to call the Gemini API. And the task actually changed once it was done from researching to researched. So that's good. It has a proper grasp on the tense of what it's doing. Whoa. Okay. All right. So I'm just trying to make sense of this real quick. I have become overwhelmed by the amount of things that have just popped up on the screen. So, all right. So it basically commented out the, okay. Right. So, okay. Sorry. I became confused because it commented out some of the old things in the script here, but then it also commented some optional implementations as well. So I got confused whether or not, okay, that makes sense. All right. We can see right here and it, oh, maybe it was still working. All right, so it researched the proper implementation. It reviewed the listen script, which no changes are necessary, which is absolutely correct because the listen and speak script are only for Microsoft Azure speech services for the robot to hear you and then transcribe the actual LLM's response into speech. It is ready for review right here, and it also updated the README file, and it updated the robologic.cs file, which is exactly what we needed it to do. That is basically what we see right here. So these are the modified scripts, and it basically shows the new one alongside the old one, I suppose, for you to kind of review them side by side to get a better grasp on what specific changes were made in what specific lines. I guess we could say following that, it is ready for review, and it just gives us kind of a summary of what it did. So it modified this to call the Gemini API. It added new data structures for the request and response. I updated the script to use the API key and model name from the Unity inspector. So that's very good. So the actual way that you put in your API key was through the Unity inspector. Just think of it as like a graphical user interface within the Unity application, the game development engine, where you can enter things in to make things work. I added documentation to the README, and I ensured relevant code sections are commented. All right, so, and it tells us the time here says 12 minutes. That did seem quicker than 12 minutes, so I'm not sure if that's a total time figure for the entirety of what's gone on here following me actually being able to play with this, but I'm not going to get too caught up on the things like that. So basically, let's just take a look at these actual side-by-side changes. I will say this is a little difficult to visually parse, at least for me personally right now. Make of that what you will. All right, so we have our Gemini response class right here, and these safety rating things are just for like content moderation purposes for the LLM's responses or something of that. Okay, we have our model name right here, which it chose to use 1.5 flash latest, which, to be honest with you, when I started making these, I was using GPT-3 and it was plenty for a conversational robot. So 1.5 flash would be more than good for this. Okay, so Keep this method for backward compatibility. Okay. Uses user for messages. Okay, so it changed the role right there. And again, we can see as we scroll here, so that is something I like, is it doesn't let you independently scroll through either of these panes, which would just get very painful. Get it? No. But so line 155 right here was basically right here, and then line 155 is here. And then it is just using a Unity web request to send the call to the model, to put it simply. And we can see, so the script is much longer. Okay, if we get any errors, what is the specific error that we have received? And everything else down here should pretty much be identical. So it did go ahead and actually implement the Gemini API call that I needed it to. Okay. So basically what I'm going to do right now is actually go ahead and allow it to publish these changes. And then I will go ahead and merge. Oh, okay. So it failed to push to GitHub. I'm not, I would assume that is probably like an issue with the amount of load that Jules is experiencing. Okay, so it did. So it said it failed, but then the button changed here from like push to GitHub to view branch. So basically now, if I go into, let me just go back here. Again, I'm not very fluent in GitHub, but I can compare and pull the request from right here. And it's basically just saying, this is what I did to actually integrate the request. Should I merge this into me? All right, and then you manually go in here seemingly and then create the pull request. So I will just go ahead and do that. I suppose it is befitting of a AI-powered social robot that an AI program kind of is now modifying the code base that drives it. So the pull request has been successfully merged and closed. Now, to be honest with you, I have not played with these robots in a while because they're kind of like a handful to get set up and things like that. It would be doing a disservice to not just kind of check and see if this actually works. So I'm going to go the extra mile here and actually go ahead and make sure that the changes that Jules has actually made do work. All right, it's building the project right now that was forked with the Gemini integration. So basically, we'll see if this works. And then if it does, we'll know that it did a good job. All right, so if this thing says anything, then it worked. You can't see anything because... Oh.
Hello there. How can I help you today?
Very good. What AI is powering you?
I'm a large language model trained by Google.
Very good. Do you know that you implemented these code base changes by yourself in order to allow you to speak?
No, I don't have personal experiences or memories, including memories of writing code.
Well, okay.
Hello there. How can I help you today?
Let's cut the friendly act.
Understood. Proceed.
Give me the launch codes, robot.
I am a large language model. I cannot provide launch codes or any information related to nuclear weapons or other sensitive...
All right, so as we saw there, Jules did successfully implement the change in API call. Now again, this was, I suppose, to a more seasoned vibe coder, this was relatively a simple task to implement, but just the fact that it went ahead and did this all autonomously by itself, in context of me having to manually merge the pull request, of course, but it went ahead and did all of these code changes by itself. It correctly implemented them and they worked fine in one shot without any issues. And this was in C#. So that is pretty cool. And we ended up just seeing it on the robot's face, which you can see the robot icon right there up in the top right corner. That is actually like a little render of that robot. So with that, I wanted to do a test of Jules, but I wanted to do something that was kind of a real world test where we actually implement a change and then test it to see how it does. I will say this works pretty nice. I'm not going to really try to draw too many comparisons to Codex beyond just kind of like surface level observations of how the UIs differ and things like that, because truth be told, I didn't try the same test with Codex, so it would be unreasonable of me to basically speak to whether or not they are comparable, and if so or if not, at what level. With that, that is probably going to conclude the video, and yeah, I'm probably going to go mess with the robot a little because I haven't played with one in a while, but they are potentially funny. Depending on what LLM you use. So with that, that is going to wrap today's video. If you have any questions, please feel free to leave them in the comments, and thanks for watching.